I think you muted me. I'm not hearing anything.
I don't think I have that kind of power. But that's
Okay.
fine. I will. I'll mute myself.
That's right.
Again.
And we'll go. Yep. And well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of May. For this month, we've got Rob Farley talking to us about advanced indexing for beginners. Before I hand over to Rob, I do have just a couple of slides to run through with some general housekeeping, and then we'll get this session running. First off, for those of you who may or may not be aware, Pass Summit is running again, this time in November, back in Seattle. If you haven't already registered, make sure that you go along, register for the event. All of the speaker sessions or submissions for speaker sessions have been completed. The pre-cons are available for you to choose from. It is a fantastic event for you to go along and learn from. With that, you're able to stay connected with Pass on everything that is happening, whether that is your local chapters, your virtual chapters like this one, SQL Saturday events, or 24 hours of Pass, which have been happening recently. With that, anybody in Brisbane or New Zealand, we do have some SQL Saturday events coming up at the end of this month. First off, we've got SQL Saturday South Island on Saturday the 26th. If you haven't already registered, make sure that you do register for that fantastic day of learning. The following weekend, we do have SQL Saturday Brisbane. So, registrations for that are still open. We do have some fantastic speakers coming from both international, interstate, and local for this event. With both of these SQL Saturdays, we do have some fantastic pre-con sessions that you can register for. First off, in Brisbane, we have machine learning with SQL Server from Ginger Grant, who's a data platform MVP. We also have a second one, which is SQL Server Practical Performance Tuning or Performance Troubleshooting with Amit Bansal, who is also a data platform MVP. Registrations for both of those pre-cons are available to you. And if you are in Brisbane afterwards, we are running a 2-day Power BI course, start to finish, with Ginger while she is here. Take advantage. It will be the only time that you get this opportunity to learn from Ginger in person for this year. Now with that, we'll hand over to Rob and get this afternoon session running.
Thanks, Warwick. That's very cool. Let me quickly show my screen. There we go. Hopefully you can see that.
Yes.
We'll see how we go. Terrific. So, for those of you who have heard me present before, I'm not big on doing slides, so I'm going to share with OneNote today, and this will be my talk. I figure that if you've joined at all, you have a clue about who I am, so I'm not going to worry about a bio slide or whatever. But if you feel like you need me to explain that I'm an MCM and MVP, etc., then ask me afterwards. So let's jump right in. What I want to talk about today is I want to talk about some stuff about how SQL Server stores its data and what this means in terms of indexing, and some of the impacts on that about the way that you can run queries and so on. And I'm going to try and do it without SQL Server at all. Okay, just work with me here. We'll see how we go. If I need to spin up SQL Server and share Management Studio, then I can do that later. But I'm going to try and do this without, because I figure that if you're a beginner with SQL Server, it's about the concepts that are going on, and I don't necessarily think I need to show you actually using SQL Server for that. I can probably do it without. Let's see how we go. So what I'm going to do is I'm going to start inserting rows into my database, and this is my database. I've got a section within within OneNote, and I'm going to write some data in here. I'm going to treat this like a phone book, like a little black book that I've got with people that I know and their email addresses, and whatever else. So I'm going to start off with Warwick's details. Okay, so this is the page that I'm going to use for my as the first page of my notebook. Just pretend with me that it's a physical one. I was very tempted to actually get a proper pen out and to use the other side of the other camera on my Surface and actually write and show you what I was writing like I would if it was a whiteboard. But I was just like, it's a bit fiddly to do that and so on. Then I thought, well, actually, I can make OneNote look just like a proper notebook. So let's go with this. Here's a page where I'm going to start writing some of my friends' details, and I'm going to start off by saying, okay, I'm gonna have somebody in here who called Warwick. Oh, my handwriting is awful. Luckily, when you store data in a database, it doesn't care what your handwriting is like. I could probably type it here, but I don't know, it's just less of an effect. So I'm going to store Warwick Rudd. He's asking me a question. Can I turn off my camera? Sure, I can turn off my camera. You don't need to see me, do you? If I wave my hands around, I'll just pretend that you can see me. So I'm going to stop my webcam. Is that what you need, Warwick? Have I done that right? No, if I do that, then it turns it off completely. Is that better, Warwick?
Yeah, it is sounding better. I think we were just losing some bandwidth with the video.
Interesting. Fair enough. Good to know. Let me go back to inserting data into here. I'm inserting some data in. I've got Warwick Rudd. I'm going to put his email address in. It's something like Warwick. I need to go to the next line at SQL Masters. I'm just going to pretend that you can read this .com.au. Okay. The great thing about writing is you know that says SQLmasters.com.au, but you don't have to read it again, so that's fine. Now I'm going to be putting a bunch of these in, so I'm going to want to store, where each one starts. The fact that one of them starts here on that first line, and then the next one that I'm going to write in is going to be one of my employees. It's going to be Martin. I'm going to start writing here, and I'm running out of space. I've got to go to the next line. So I've got Martin, Kenny, and I'm writing data in here, and his email address is martin@lobsterpot.com.au. Now, you see one of them starts here and one of them starts here, and I'm going to want to know that for when I want to access this, when I'm looking at stuff in my phone book, I'm going to want to know where each one starts and so on. If I try and make that list up here at the top, I don't know how many I'm going to be fitting in here. That could be a problem. So I'm not going to store it there. I'm going to store this at the bottom so that I'm filling up a gap this way, and my list of who is where will go this way. Okay, so I'm going to say, right, my first row, I'm going to say, because I'm a developer type person, I'm going to start with 0. I'm going to say this one, my first one starts here on line 1. Great, at spot 1 in there. Okay, my second one, which is number 1, starts on the second line over near the end. I'm going to say that's about 20 characters in. My third one, when I write somebody else in there, maybe one of my other employees, Manohar Puna, with his details and so on, and that starts here. That's on the 4th line, and this is this person here. 4th line, about halfway in, maybe 10 characters in. And this way, my list of details fits in much better, and I can just access them according to what I've got down here as I need. And because that's right in front of me, there's no problem to be able to go, oh, yep, sure, that's there, that's there, that's there. I can deal with this. And a computer can deal with this as well. These are just addresses within a short amount of space, no problem. Okay. Now, this particular, it thinks I've written time away. Will Rudd was Wyatt Sam. I love handwriting recognition. I totally get that my handwriting is not good. Anyway, As this fills up, I get to a point where I've run out of space and I might need a new page added, and I can continue going with that. And I probably want that to look like a, I don't know where to change how it looks. Rule lines, there we go. I'd be able to write more on that page, not a problem. And somewhere I would actually need to have a list of pages. So this might be pages, and I can say, you know, pages in my list, and I've got page 1 and page 2 when I go across to there. Right now, this is information which is in no particular order. It's not ordered at all. All I can see is the order that went in, but that's, you know, but even then I can't necessarily guarantee that it's going in that order. All I can really tell is that I have data in a few different spots. In database terms, this is what we call a heap, and the pages actually look very much like this, with all the data there, the list of, you know, the list of the slots, they're called, in the bottom here, and it's pretty good. I could have extra processes run stuff to be able to push more and more data in, and so long as I need to call this something. I'm just going to quickly type at the top here, because it's a list of pages, to try to give it a title over on the right hand side. It's not going to, it thinks there's a dot somewhere. How annoying is that? There we go. That's better. Use the eraser and get rid of some stuff. Right, so long as I have a page in my list of pages, I could have, well, not page 3, because page 3 is my list of pages, but I could have a whole bunch of stuff, and I could have separate processes write. You know, I could let other people write at the same time that I'm writing into my phone book. If I wanted to get a whole bunch of stuff in nice and quickly, this could be quite convenient. The pain is that it's completely out of order. Even if I wanted to find somebody, if I wanted to find Warwick in the thing, I've got no idea where he's going to be, and I'm just going to have to look through everybody in my book to try to find Warwick. I get that he's at the start in this case, but I don't know that ahead of time. I would just have to look through all of them, and this is where indexing comes in. So with indexing, what I would do is I would say, let's add a new page, and be able to say, here is my people by last name, and what I'm going to do is I'm going to say, okay, I've got Rudd. Okay, that's one of my last names, and Rudd is on page 1 in slot 0. Okay, and then I can say, right, and I've got somebody else. I've got and down here I have I say my first row in here is for Warwick, and he's on. I was going to do lines. Let's just pretend he's on line 1, starting at starting at the start of line 1. And then I'm going to say, okay, my other people in here, I've got Kenny, and he is in. He's also on page 1, and he's in slot 1, because this stuff here, the page and the slot, that's effectively the address of Warwick's details. Because I might be able to find Warwick this way, but then I've got to look up the rest of his details, and they're stored according to what this address is. Now, when I've just put Martin in, I need to be able to indicate that he's down here, except for the fact that Kenny is alphabetically before Warwick. So what I need to do is actually I need to say not this anymore. Now, my first row in here is actually the second one, which is about there. And Warwick is now in the second slot, in slot 1 instead of slot 0. But this is a small amount of bit to replace. That's a small amount of data compared to all the stuff that might stock up in here. My list of my list of the slots is a relatively easy amount of data to replace every time I need to insert. Then I'm going to put Manohar in. His last name is Punna, and he is in 1, 2. And down here I've got in the slots section, I need to put him in between. So I need to drop him in here and say Warwick is now slot 2 because he's last in the list, and Manohar's being put in the middle, and he's also on line 1 starting at about position 20 or so. I'm just making this stuff up, of course, right? But you can see in here, I'm able to put a whole lot more information into this, and it's in order because it's a copy of a subset of the data. There's not so much information there, but it's nice and tight. If I'm wanting to find people by last name, this is the way that I want to go. I can access them in order just by going, it. This one's first, that happens to be here. This one's second, that happens to be here. This one's third, that happens to be here. And I can do that just as easily as if they were in order in this section up here. I don't need them to be in order up there because I can access them in slot order down the bottom. What happens though, if this fills up, then I have what's called a page split. And at that point, I've got to then figure out who goes into which one. And there are 2 ways that happens. If I'm filling them up and I want to try and insert something at the end of the page and I've got no space, I'll just tip over to a new page. If I want to insert one in the middle, then what I'll do is I'll do a horrible type of page split where I actually move half the data into one page and half the data into another page according to what's halfway through this list of slots. If by the time I get to a page slot, I've got like 200 of these, then my page split, so long as I'm not trying to insert into slot 201, then my page split is going to go like roughly halfway, about 100. It's going to move 100 rows into a new page, and it's going to say, yep, I now have a tree going on, and that's going to look like, here's my page. Well, let's do it this way. Here's my page, because my list over on the right hand side is vertical. I'll do this like this as well. And then I need to have another page which describes where the boundary is between these. So basically I'll take the last row in this one and say, yep, that's that one. The last row in this one and say, yep, that's that one. So that when I'm looking for a row, I can check in here to figure out where I need to head. Now, these addresses become a bit tricky, because what happens is that if I'm back on this page and I don't know, we need to change somebody's details. So for example, what happened at one point was that I got another Martin in the company, and I need to make sure that I wasn't listing Martin's email address as just martin@lovespot.com.au anymore. So he became martin.kearney, and all of a sudden I'm needing to update this row in here and make it bigger than the amount of space that I've got. Well, that becomes a bit of a pain, because I need to get rid of that, and I need to put it somewhere else, maybe on the next page. Here's the new row for Martin with more information in here. But what's going on with this is that in my index, I'm referring to Martin as being on page 1 in slot 1. This becomes a bit of a pain. I don't want to have to go through and change all my indexes just because I didn't update and couldn't have him listed there anymore. So what goes on instead is this becomes a forwarding row and says, oh, okay, actually, this becomes a forwarding record. It says, go and find this row. When you want to access this one, go and find it over at page 2 slot 1 instead, or wherever that happens to be. We have a forwarding row. So then if I'm looking them up by last name and I found that Kearney is here, this one here, I then go in here and I go, right, I've got that information. When I want his email address, but I'm looking up by last name, I can't, the email address isn't in here. I've got to go hunting for it. And at that point, I follow this address to page 1, slot 1. And I go, great, that's 220. And I come here and I go, oh, that's a forwarding record. I actually need to go to this other page and find him here instead. Okay. This is one of the things where a heap might be really good for some things. It's great for getting data in fast, but you start to find that you might have these slots that are no longer something's address, but because we don't want to have to go and update it everywhere else, we put a forwarding row in. There's also the thing of saying, of saying at some point we might decide that we want to delete somebody from the system. It's all well and good to be able to get rid of that row, but a heap doesn't then let us go and try and squeeze more data in, because this slot it could be used in all kinds of spots. So until we rebuild the heap, we just end up with blank spaces wherever we've deleted anything. That's a type of fragmentation, and effectively means that when you're looking through all of the data, when you're scanning all of the data, then you'll be looking through more pages than what you need. I once came across a customer who, and they're happy for me to tell the story. I'm not big on telling customer stories, but they've said that I can tell this, where they were having bad performance on a table that they considered was a temporary table. They didn't actually use it for anything except to store data temporarily. But it wasn't a temporary table that they were dropping. They were keeping it around. It was a proper table. They would just put data into it and then delete it when they were done. But it was a heap, and so they would put data in. That would be great, but they would delete it, and it would leave the pages with the empty slots there. And this thing was growing and growing and growing. It was like 400 meg in size, and it had 8 rows in it. And then shortly after, it had no rows in it, but they were all just pages with lines through the data. It was quite strange to see. And they could have fixed that simply by rebuilding the heap, or by not using a heap. A heap is great for getting data in and for having data that we don't care about the order. And you can index it nicely. There's no problem with that. And in fact, because we know that we're going for page 1, slot 1, we can go straight there, and that can be really handy. But, and find the data, get to the data very quickly using what's called a row ID lookup. But there are drawbacks to heaps around fragmentation and so on. If your system is insert only, then a heap might be great, because you can easily insert data, not a problem. You can use your non-cluttered indexes to be able to, your extra indexes, which are going to be tighter and which are going to be having addresses that don't involve forwarding records, because you're only inserting, and it can be a very effective way of dealing with your data. But you often hear a lot of people say bad things about heaps, and there's good reason for that. Now, I mentioned that thing about lookups. Now, in this index that I've got here, I'll just get rid of some of the annotations that I've put in there. I've made this non-cluttered index to be able to say I want to have this ordered by last name. When I say ordered, what I mean is that I'm in my slots down at the bottom here, this section here, that this maintains the order on the page, and in a way that when I have a page split, it can tell which halves it needs. Now, when I'm looking for a particular name, if I'm looking for Kenny here, I come to this page. I don't know whether Kenny is going to be at the start, at the end, or what. I'm just going to go halfway through the list of the slots, and then I'm going to go, is it more or less okay, and then go halfway in there and halfway in there and halfway in there and halfway in there until I find the particular slot that I'm interested in. But that's a very quick operation, and because this is a small amount of memory which is taken, it's all in RAM. It just loads up an address space and goes straight to it. It's a very quick operation. The key is to be able to find out which page we've got to get to, and that's where the levels in the indexes come into play. Whether we're looking at that page or that page, we can tell. The non-cluttered indexes are very, very useful for this. Whether it's on a heap or not on a heap is very useful, because it's ordering it in the way that we want. Now, the thing is the fact that having ordered data is the kind of thing that means that you can find the one you want easily, because it's in order, right? If I were in a room at a conference, I would actually probably get people up and say, let's have an index by height, and just like you do in school, and we make everybody stand in height order. And then when we're looking for the particular person who is 5'8 3/4, we can very easily find that spot. We don't start at the beginning and move all the way through. We just go, okay, let's go halfway and then split, and we can find the one that we want very easily. If we needed to split them into separate groups, we could do that, and that wouldn't be a problem. The thing is the fact that that way the whole person is there in that, in that list and has all the information that we care about. In a non-clustered index like this is very tight, but doesn't necessarily have all the information that we want. So if we're looking for that, if we're looking for email address, for example, we might find somebody with the right last name, but then we need to go and look up what their email address is on a different page. And that could be a bit of a performance hit. What we want to do is say, I get that this is nice and tight, but I'm willing to forego the tightness of this, how many I can get on each page, because of the convenience of also storing some more information in there, like the email address. So at this point, what I could do is I could say, right, when I'm inserting the rows into this index, I could actually have done it a different way and said, this is Warwick, he's at that address, and we're also including his email because that's the useful information. We're not going to bother with his first name because, or any of the other information that happens to be there. This is the information that we want. And then we have Kenny, and you can see that our slots, we're not going in as tight. This is going to be spread out more. So then I've got Kenny. He's at 1.1, and his address is Kenny at lobsterpar.com.au, and so on. It's still tighter than what we had originally because it's fewer columns, but it's the columns that we want. At this point, if I'm looking up somebody's email address by last name, it's there in the index already. This suddenly becomes very convenient, and it saves us having to go back and do that second read. It's very, very useful. So at this point, I'm using non-clustered indexes with included columns to be able to save on lookups, and I get to be able to have a very good experience with this. And it's totally irrelevant about the fragmentation at this point here. My heap might have, my underlying heap might have lots of gaps in it. It might have really bad fragmentation, lots of forwarding rows, all of this kind of stuff. It might be awful underneath. But if my index, my non-cluttered index on top is tight and has the information I need, I can get to it, see what I need, and get out and get the answer back to whoever's looking for it. It's very effective. It's very useful. If I were needing to list my email addresses in last name order, this is tremendously handy. I can just go through here. I can produce them. I don't need to do any reordering of that. They're coming back in the order that I want because that's what's going on. Now, when I have a page split though, the information that I need to store at the next level up doesn't include the email address, because all I need is enough to be able to know which row I'm looking at. And so that this level here can be even tighter. It can be as tight as what it was before I had any included columns. And that becomes really handy. I do still need to include the address there because I still need to uniquely identify which row is which. Suppose I had a whole bunch of RUDs. If I've got Warwick's wife and his brothers and his, mum and dad and all that kind of stuff in there, I might have lots of RUD information in there. I'd have some very ruddy pages going on at that point, and just if I just said, okay, this page ends in a RUD, I'm going to want to know which RUD it is that I'm considering here. So go on.
So Rob,
have you got
just a question. I do have a question for you. So does truncating a heap take care of the fragmentation issue?
Well, if I'm truncating it, then actually I'm resetting the table completely. So yes, doing a truncate will clear it. It also clears all of the content of the indexes and so on. Yeah, that effectively that wipes out any pages that are involved completely. It's deleting won't. Deleting, even if you say delete without a where clause, it will go through and actually delete each one and leave the pages intact. But truncate is not actually a delete operation. It's actually an alter table operation. And you'll know this from when you do permissions, that you need to grant somebody alter table permissions to be able to let them do your truncate. If you don't know that, then you're probably giving people more access than they need. They're probably running as DVO or something like that. But yeah, truncate will actually wipe all of the pages. All of these pages along here will just get wiped, and the table will be completely reset. It's almost like doing a drop and recreate, except that every aspect of the of its structure and so on is kept.
Excellent.
Okay?
Thank you.
So but what's going on with this is that we need enough information at this higher level here to be able to guarantee which row it is that we're talking about as the last row of any page that's going on. This has an impact as far as if this index were created as unique. If we knew that there was only one RUD in the system, then at that point up here I can say, sure, just identify it by the name RUD, and that will be enough to uniquely identify it. We would know that in the next level down there's only one RUD, that's the one we're talking about. And at that point the address is also not needed on the next on the higher level pages of the index. Let's think about a new table. At this point I want to say, let's do something very similar to what we had in the first case, but we want to do it in we want to have ordered data in our underlying pages. So remember we had this, it was not ordered at all. We just added new things. We just added to the slot count at the bottom. It was easy. It was quick to insert into. We didn't need to think about where anything needed to go. We just put it in there. Not a problem. For a different kind of list, we might consider that we want to order that data in the bottom. Effectively, what's going on here now is that we still insert stuff in the same way. We still start by putting Warwick in there, Warwick, Rudd, Warwick, etc., 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 and then we put our next one, Martin, Kenny, whatever, and then we put the next one in, Manaha, Puna, whatever. Maybe I'm in there too, Rob Farley, because I keep forgetting my details. At this point though, as I'm maintaining this, I start with Warwick. Suppose that I want to order by last name in the underlying system. So I'm ordering my whole table. When I then put Martin in, I need to make sure that Warwick moves to here and that Martin is kept in here. And I'm maintaining the order just like I did in the non-clustered index. I'm maintaining the order down here. I still have page splits in the same kind of way and so on, where if it's going at the end, I can just fall over to the next page. But if it's going anywhere but the end, I need to split the data half and half. So I end up with an ordered list down here. Hang on, Martin, then it's going to end up with my row being next, which is on line 5. And the next one is going to be and then Warwick's going to be the last one, and that's 3, I don't know, 20. So this is this bit down here is the bit that reflects our ordered data in what is now something that we call a clustered index. I don't like the word index for this, because really it's no different to an ordered heap. It's our underlying data. It's just that it's maintained in order. All our data is there. When we insert, this is where we're inserting into. Anything that needs to access it, if we had an index on it, then our address is now different. Because what happens at this point is that if we have a page split, we move half the data from one page to another. In fact, we can't even rely on saying page 5 slot 2, Because when another row comes in, it's not going to be page 5 slot 2 anymore. It might be page 5 slot 3 if it goes in beforehand. We don't want to have to go and update every single, everything that would come after that. That would be awful, having to, you insert one row and then you have to go and update every single reference to every single thing that appears after it in the page. That would be awful. So instead what we do is we use the clustered index as a way of being able to say, this is the row's address in the system. The address is the things that we've got in the clustered index. That's how we find it, because it's going to move, Otherwise, we'd be just like, well, I don't know where this row was anymore. I need to go and find its email address. That's awful. So we need to be able to identify which row it is we're talking about. But I get back to my problem when I want to include the rest of Warwick's family in there, is that we need to know which RUD is which. We need something that uniqueifies our data, that says which is, which is this the same RUD as what I was talking about before. So at that point, I need to be able to say, as soon as I get a second RUD in there, I go, when I come in here and I say, and here I've got somebody else, and I'm going to say this somebody else is going to be RUD v2 and have a uniqueifier on there. And if I've got a whole bunch of RUDs in here, this will be RUD 3 and RUD 4. Actually, the second one gets a number 1, but that's just the whole thing of, do you start counting at 0 or do you start counting at 1? And I get lots of them in there as a way of being able to say which is which. Now, the old advice about putting a identity column on and making a clustered index key on that is simply the whole thing of saying, well, as you're inserting rows in, if it's always increasing, then you're going to always be inserting into the last slot. So then you're inserting here and you're inserting here, and when you run out of space, you just tip over to the next page. Not a problem. You don't need to do that half and half split. But what order is this in? It's not really in an order. Sure, we've got all these unique things, but then it comes back to saying what's going on with our addresses here. Our address really at that point just becomes, instead of being 1, 0, we're saying, well, this RUD happens to be person with person ID of 1. Some other RUD might be person 7. And we've got this surrogate, this made up value, all because we want to make sure that when we're inserting, we don't have page splits, we don't have that fragmentation introduced by page splits, we don't have the work of trying to copy half of the data from one page onto another. But when we think about accessing data in order, well, that's, potentially it can be quite useful. I'm not trying to go against the advice about saying just put a nice identity column on every table. It just comes down to trying to think about how you end up using your data. I often see people who have like an address table, and they have just address ID whatever, and they access the data by address ID. Now, I like to think about whether that's how you get to that data or not. If actually you tend to query it according to the person ID of the address, then maybe having the person ID as the clustered index key could be quite useful, because you can join to it. It's there. Sure, when you're putting data in, you're squeezing data in, and you're having to rearrange the pages. If it turns out that you're trying to squeeze data into a page that's not there, or you're updating a row and finding that it doesn't fit anymore. But otherwise, you're having to look up in a separate index by person ID, finding the address, and then going and looking up somewhere else. So maybe it's potentially, a bunch of extra work. Also worth considering that when we've got data, where was it? Here, when we're addressing, when our address is like, row 7, and we've now got a whole, a whole tree of data, we can't go straight to the row anymore. We have to look up to try and find row 7. We have to seek through our data to find that row. That can, in a large table, that can be quite a bit of effort to do that. Now, what I also want to talk about, though, it's all well and good to be able to take advantage of ordered data to be able to find the particular person that you're after. But understand that that quite often that's not what you're doing. You're looking for data that isn't indexed, or you're looking for data where you know something about, like for example, we might know that it's a RUD that we're looking for, but we've got like lots of RUDs in our system, and we're looking for the one where the email address is something else. We need to go and find the start of the RUDs in our index, go through and find it, and then search through all of the RUDs for the one that matches this extra criteria that we need to look it up on. At that point, one of our predicates, one of our conditions for finding something might be great for going and hunting through our data. I can do that using this index. I can find the RUDs, I can look through the slots and find out where the first RUD appears, the one that where the previous record is not RUD, but the one that I found is a RUD, and then I can say, great, this is my starting point. Now I can search through everything to go, making sure that we're still looking at a RUD and checking other criteria to find out if I should actually be returning that row or not. This is called a seek predicate versus a residual predicate. The residual predicate because it's the one that's left over after we've done our seek. And this is the cause of a ton of pain with indexes that a lot of people don't really appreciate significantly, because what's happening with this is that you've got what looks like a really good index. You see a seek operation going on, and it feels like it's really good, but actually it's having to look through a lot more data than what you're actually interested in. So you can imagine this though, right? You can see that in my notebook, and this is where if I feel like if I had it on proper paper, I would be, being more careful about what I'm writing, and I wouldn't cover it in scribbles and all that kind of stuff. That I could find all of the RUDs that I'm after. But if I had to look through pages and pages and pages of them, it would be a lot less useful. If I'm looking for Smith in the phone book, I might have to look through lots of Smith to find the one that lives in the suburb near me that I'm trying to look for, or whatever the case may be. Understanding what you can do by having multiple levels in your indexes, potentially, to be able to say, I can find, if I'm looking for by RUD, looking for a particular email address, then maybe I want to actually include email address in the key of my index rather than just as an included column. That means that when I fill up these pages here, I might I would need to include the email address in here as well, and at any going further up. So it can become more expensive. But if I typically need to look for people by last name and email address, then that could be quite useful. Understand, if I'm just looking for them by email address, it's not useful at all. I don't go into the phone book and look for people called John without knowing that their last name is Smith, because I would have to look through the whole phone book to make sure that I pick up John Aronson as well as John something that starts with Z. But so a composite index, an index with multiple levels, only works if I know what the first one is, what the first level is, to be able to then continue my seek into the second level. But it still can be very useful for the way that I organize my data and so on. Now, if my clustered index keys are particularly long, then understand that if I had last name, first name, email address as my clustered index key, the address is long of everything that I'm looking for. At this point, every single other index that I've got needs to include last name, first name, email address in it the whole way, because I've said this is how to arrange my data at the very lowest layer. My address of each row is now much wider, and if I include that in any other index, any non-clustered index, I've got to include all that just so I can find the row that was the underlying one. In some ways, a heap where it just goes, this is the address, it's page 1, slot whatever, worst case there's going to be a forwarding row in there. That's a much tighter address to be able to use. I never need to worry about how wide that address is and so on, because it's completely impractical. If I have it, if I'm using a surrogate key, then sure, it's nice and tight. That's a great benefit to it. But I have to go and search through and find it every time. It's meaningless. It might be useful if I'm referring to it in another column as a foreign key than in some other table. But it offers no practical business use to me. As far as the business is concerned, it's just a number. It doesn't count for anything at all. So anyway, I've talked a bit about seeks, and then the fact that when we reach the bottom, we start actually scanning through the data. It's called a range scan, because it's not a whole scan across the whole thing. It's just a particular range that we're scanning across. It's everything that satisfies that initial seek to find the RUDs before I need to look through and find the one with a particular email address. I do a seek followed by a range scan within that seek operation. If I were doing a seek across the whole table, then sure, I'm starting at the whole index. It doesn't matter really whether it's an index scan or a clustered index scan or a table scan. If it's a table scan, it means there's a heap at the bottom. That just starts at the first page of that index and moves through from page to page. That's checking every single one and not taking advantage of any seeks. That feels like it's really painful. Although if it's a tight index on just the things that you care about, that might not be too bad. It might be that you do need to look at every one anyway, and that you're not even having to filter with an extra predicate. But still, think about what's going on with that. Now, the best type of index scan for me is if our index is actually only the things that we care about. Suppose I knew that the RUDs were a special case. I could say, okay, let's actually have a filtered index where I don't even include the other people that aren't RUDs. At this point, it becomes really tight. I've got RUD, I've got RUD, I've got RUD with the addresses and so on in there, but I'm fitting a lot more onto the page. And at this point, I'm more than happy to scan that whole index when I want to, because it's ridiculously small. I might have 1 million people and only 10 RUDs, but if those 10 RUDs are the ones I need to look up all the time, a filtered index becomes really handy, and I'm more than happy for that to be a scan on that index. It's like having a whole separate table. And in fact, you often hear people say a table is really an index, but in many ways, an index is really a table, because it's a copy of the data. It's a copy of the pieces of data that you're interested in according to the filter that's on the index, and only the columns that are indexed. It's in a separate order. So it's like having a separate table of that subset of data with a clustered index on it. It's maintained the same way, the pages moved in the same way, all of that kind of stuff. It's like having a separate table. And in fact, when you think about how you're interacting with your data, think about the indexes you've got in place. That way you won't be tempted to throw an extra column that's going to mean that you're going to have lots of lookups going on. Think about the design of your indexes when you're designing your tables, so that you can think, yep, and we'll be able to access data like this through this index being a copy of the bits that we care about. I know environments where they constantly, like every few seconds, they're looking for particular edge cases that are going to pop up. There's orders that are over a particular threshold or whatever the case may be. And I've seen And I've seen like systems be ground to a halt because every few seconds they're scanning or even doing seeks on large tables. And my take is, you know, if you had a filtered index on that, then that's basically like saying, let's keep a separate copy. Let's keep a separate table which keeps a copy of the ones that we care about, our edge cases. So life carries on as normal. And every so often, when a large order, for example, gets put in, it pops that large order, a copy of that, into a separate table. So if we're polling that separate index, it's normally empty. It normally comes with saying, yep, nothing there, nothing there, nothing there. Very fast operation. But on the odd time that there's something in there, it just goes, oh, yep, here's a row, and you can go and deal with that and, you know, do whatever you need to, flag it in some way so that it no longer appears in that table, and your constant checking can keep going. It can be a ridiculously effective way of handling that by understanding that really each index is a table. It's a copy of data, and it's just like one that's got a foreign key back to the original underlying table, so that you can join back to it in what's called a lookup to be able to get that extra information. So anyway, we've talked about some ridiculously advanced topics here. We've talked even about the way that data is stored in a physical table, and if you actually do a dbcc page command, you'll see that it does actually look like this. But understanding what the impact of that method of storage is on having your non-clustered indexes, this one here, your non-clustered indexes, whether it's on top of the heap or on top of the clustered index, whether you put filters on there, whether you use composite index, what's going on with your seeks versus scans and range scans as well. There's a lot of concepts in there. Understanding what goes into the higher levels of your index to be able to keep your indexes tight, to be able to have as few pages as you can, which therefore impacts the concepts of fragmentation and so on. What I want you to be doing is thinking about the usefulness of having your ordered data. It can be useful for finding the data that you're after, but can also be useful for grouping the data, for counting the ones in a group. And when you think about filters even, it means that you can actually say, I want to be able to keep a whole separate copy. In many ways, if you think about indexes as being tables that, because of the order, you can access ranges within that table very easily by just throwing a seek into it and saying, hey, I'm now dealing with this data here. Think of it as being separate tables within there, such that you can imagine, okay, and then what order is that data in when I get to that range? Is all the data that I need there, or do I have to go and find that in, you know, the underlying table? Do I have to be able to join back to that with a lookup? And of course, you don't do that with the query, but in the plan, you'll see the join going on. If you think about what's going on, if you understand this concept and how it relates to the paper-based thing that I was describing at the start, then actually you'll start to approach database design and querying in a very different way. You start to think about, well, hang on a second, if I don't actually know the surname, then my data is not in that order at that level, and so on. There's an awful lot of concepts here that simply make more sense when you think about what's going on behind the scenes. You know, people think about a database as being a really complex thing that allows all kinds of interesting data access methods and so on. But what's going on is that the database is designed around the paper-based system. I mean, come on, if it didn't work on paper, it's going to be slow with a computer. You know, the fact that when we split pages, because if you're trying to fill up a filing cabinet, when the filing cabinet is full and you need to get a second one, to make best use of having that second page, you're going to take half of what's in the first filing cabinet and put in the second one. It's a page split, really it's a filing cabinet split because you're taking half that data and putting it into a second one. But if you knew that you were just adding on to the end, when you get the new filing cabinet in, you're just going to keep going, and leave all that space in the second one and not do a 50-50 split. All of these concepts, all of them relate back to the way that it works on paper. So if you can imagine the way that it works on paper and start to grasp that when you think about the way that the data works, it stops being magic and it starts being something that you can leverage for performance and for the results that you want when you do querying and design and so on. You start to understand the impact of fragmentation. You start to understand whether you should rebuild your indexes, what rebuilding means. If you're rebuilding a heap, then all your addresses change, and that's going to impact all your non-clustered indexes that refer to them. But if you rebuild a clustered index, then your addresses don't change. Rudd Warwick is still Rudd Warwick and can be referred to that in your non-clustered indexes. That doesn't change, even if it's Rudd Warwick version 3, because of a uniqueifier. That address doesn't change. We can rebuild the clustered index without needing to rebuild the non-clustered index. It makes sense when you think about what's going on paper, and it means that it's less about trying to learn the particular rules and say, okay, it works like this, it works like this. It stops being just something that you need to, like a word in a foreign language. It starts to be something that relates to something that you understand. You understand the concept of paper. You understand the concept of how you have an address. The fact that if you change the address, you've got to update anything that refers to the address as well. Understanding these concepts, understanding what you would do on paper, actually impacts the way that you treat your database. Warwick, do we have any other questions that have been coming in?
At this stage, no, but if given that we are nearly at the end of the session, if you do have questions, shoot them through now and we'll be able to get Rob to answer those questions for you.
I'm hoping that I've explained it in such a straightforward way that nobody has questions. And they've just gone, that makes a lot of sense. Feel free to ask a question which is just giving feedback instead of asking a particular question. I'm always happy for a question which is actually not a question, but feedback instead.
So,
nothing.
Rob, with non-clustered indexes, with creating a non-clustered index, should someone always look at creating a non-clustered index on a foreign key?
So I think actually your question is, I want to rephrase your question, because you create a non-clustered index wherever you need a non-clustered index. You shouldn't think that you need a foreign key to be able to create a clustered index. But I think what your question is saying, if you have a foreign key, should you create a non-clustered index on that, right? And the thing with that is what happens if you want to delete the row in your first table. So for example, if I have two tables, if I have a table which contains, orders and another that contains line items within the orders, if I don't have that order ID indexed in the second table, then when I do a join, or if I want to delete something, then I can't easily find that row that, any rows that will match the row that I'm starting with in my order table. Now, if I can imagine that I would normally go the other way, then it might not impact it so much. If I'm starting with if I'm looking for times that I've bought a particular product, and I then want to join to the order, not a problem. I'm joining through the foreign key, that I'm hitting the primary key on the other side. That's nicely indexed, not a problem. The problem comes when I want to go the other way. If I want to delete the order, if I want to find the line items within a particular order, then I'm going to feel like I've got a lot of pain if I don't have that foreign key value indexed. So I would say by default, yeah, anytime I create a foreign key, I'll also create an index on that. But mostly for the sake of join reasons and so on. As to whether it's helping particular queries to say what columns should I include in there at the leaf level, at the very bottom level of the index, well, that comes down to saying, am I typically going to be joining that way, and do I care what other information is there? If my foreign key is there to prevent accidental deletion of orders that might have a line item still, then I'm happy just to use one column, don't care. If I typically need to look up more information within the line item, I'm going to want to include extra information to avoid lookups. I'm not a big fan of lookups at all. My take is that I would rather spend the effort maintaining a non-cluttered index than to have to go and keep doing a lookup every time I want to. I need to access data within that, that insufficient index. Does that make enough sense? So I think the answer is yes. It just depends on how the question is phrased.
Okay. Should I consider a covering index compared to two non-clustered indexes, i.e., query 1, I have a where condition and I'm hitting columns 1 and 2.
Yep.
And in query 2, I'm hitting columns 2 and 3, but I'm retrieving the same amount of data or the same data in my select. Should I just create a covering index, or should I look at creating two separate indexes?
Sure. There's a certain amount of it depends in here, because two separate indexes might be able to help you have tighter indexes for general use, and it might be that that in tuning you want to have something, if typically you don't need that extra column, then maybe for performance's sake on the rest of it, if 90% of your workload is going to take advantage of a tighter index, then having that tighter index can be really useful for that. For a query that involves two, you do see a thing which is called index intersection, where it can look through two indexes and do a merge join between them, looking for the overlaps, looking for the intersect between the two, and that can be quite effective. But still, it requires a join between those two indexes rather than just going into the one and having all the information there. Having all the information there is almost always going to be better. It's just that it does make that index fatter. It's going to be across more pages. So if it turns out that makes your index 3 times the size, then it might be that you're adding 3 times the workload to 90% of your activity on your table. In which case, well, it might not be such a good idea. But you may find that actually two very similar looking indexes might actually be in play there. It's interesting because you see a lot of talk around the place about indexes that are effectively duplicates of each other, and there are queries you can run to be able to say, do I actually have two indexes that are effectively the same, such that I only really need one of them. One of them is just the same as the other, but with some extra included columns, for example. And quite often that can be a thing to look out for, and to be able to say, okay, I don't necessarily need that thinner one. That larger one will do the job for the thinner one as well. It's just that if you are hammering that thinner one, you don't suddenly want to make it much larger. And so understanding how you use your indexes, thinking about the paper-based system, thinking about whether you might want a smaller number of pieces of paper to be able to go through, rather than having a book that's got a lot more information. The book with a lot more information is going to be more useful for general purpose, but if you're typically just picking up a handful of sheets of paper because all the information you need is in there, then if you imagine it in paper, maybe it's okay to have two very similar overlapping indexes in play. So typically covering indexes are better, but you've got to think about the workload.
Okay.
Does that answer the question? Are these your questions or are these people from the audience?
A bit of both.
Okay, cool.
Now, if I was looking at a execution plan,
sure,
and I saw a key lookup, is there a rule of thumb that I can go by to say I need to expand my index and have an include column, or not worry about making any modification, and I'm happy with the key lookup?
Sure. So I understand the key lookup is potentially going to be quite painful, particularly if it turns out that your stats are out and where you think you're going to be doing 3 key lookups, if you're actually doing 3 million key lookups, that can become very painful. So stats are very important for understanding whether that's in play or not. You might find quite quickly, you'll find that it'll just go, you know what, that index doesn't work because of the expense of doing the lookups. I need to go to a different index, which potentially even a clustered index, and maybe do a hash match instead of a nested loop join to be able to avoid that ridiculous number of key lookups that might be coming through. Whereas the cost of having an included column, you might have something that is relatively tight, avoid the lookup, it might work really nicely. What I like to do is I look at the key lookup and I see what the output columns are in the key lookup. That tells me which columns is it needs to go and fetch. I also look to see if there's a predicate on there, just in case it's doing an extra check, and to see if it might not be returning the row, but it might be looking at a row, because that tells me how much I'm needing to include in that first index, the insufficient one, to make it a covering one for that query. If it's like, almost every column in the table because my query is a select star, well, I need to stop using select star and look at what I'm supposed to be doing there. Quite often you see people testing what's in a view, for example, and the view is returning way more columns than it cares to, and in real life you're not going to be doing that. So you need to figure out what is the real use of the query, but then look to see how much is being returned. Quite often it's because a single column has been added. You've got a key lookup in there just to be able to go and fetch the discount rate, for example. In which case, just add discount rate. If there's one thing that's being returned in the key lookup, just add it as an included column in your index and be done with it. If you've got 10 columns that are coming back, then maybe you need to rethink what's going on with that indexing. It might be that that included columns will do the trick, but there you've got to think about what the impact is on your paper-based system as well. Think about whether it's going to mean that you start looking through a book instead. Think about what it means for updating. If you update one of those values, you're going to have to update the index a little bit as well, because you've got a copy of that information. Does that answer that question?
Yes. Okay, so we may have to get some more feedback on this particular. I've got 4 questions which interrelate. So first, a table has a clustered index. Why does there exist a heap index?
A heap index? No, so if a table is either ordered or it's not ordered in the underlying data. If it's ordered, then we call it a clustered index, and the keys of that clustered index are the order in which the data is maintained. If there is no order, then it's a heap. So where I gave an example here of saying this would be a clustered index and this would be a heap, these are different things. It's either a clustered index or a heap at the bottom level. Any additional indexes are non-clustered indexes. They're just regular indexes that are not the underlying table. I hate the name, maybe not hate. I really don't like the name. Hate's a strong word. No, I hate the name clustered index. I would just wish it was called an ordered table. To me that would make a lot more sense. And then we could just call your non-clustered index could just be called an index, and we'd be much happier. A regular index. Think about it that way. There's regular indexes, and there's the order of the table. When we see clustered index, it's just order of the table. It's an ordered table. think about it as like key ordered or something like that. Oracle calls it something similar. But yeah, you wouldn't ever have a heap if you had a clustered index. It's the two are mutually exclusive. It's either a heap or it's a clustered index. I just hate the terminology. It's just it means that people talk about things like how many clustered indexes can you have on a table, and it's just like, okay, you're missing the question suggests that you're missing the concept. If when somebody says, "Oh, here's a typical interview question," I just go, all that does is say the idea of how many clustered indexes it's nonsensical. It's like saying how many heights can a person have. It doesn't make sense.
So you could have a clustered index, or you could have a heap, or you could have a clustered index and one or more non-clustered indexes, or
by all means.
Or you could have a heap with one or more non-clustered indexes.
Absolutely. The concept of saying, is it a heap or is it a clustered index, is entirely separate to the non-clustered indexes, the other indexes. Now, we didn't talk about Columnstore today. Columnstore, when you think about clustered Columnstore, that's saying this is the underlying table. The concept of clustered is saying this is what's going on with the underlying table. If you have a non-clustered Columnstore, that's basically saying this is not the underlying table, it's a separate index on top. But yeah, the concept of, it's just think about it that way. Clustered means the underlying table, and a heap is the underlying table if there is no cluster on it. The non-clustered stuff is the separate useful indexes that sit across the top.
Excellent. Okay, well, if we have no further questions, I'd like to say thank you to Rob for coming along and being our presenter this month. I'd like to thank all of the attendees for coming along and being part of this session. One thing that we didn't mention at the start of the session, this is being recorded and will be available on the DBA Fundamentals archive site in a few days' time, where you will be able to come back and yes, Rob's session is now immortalized and available for you to watch over and over again. I look forward to having you all back again, same time next month, where we will have another wonderful session for you. In the meantime, have fun. Thanks, everybody.